Okay, so if we don't know what the word converse means, what could we do to find out what the word converse means? What could we do? What could we do to find the word converse? What could we do to find the word converse? What tools do we have in a classroom that we can use to find the word converse? Go for it. Okay, Christopher, what did you figure out the word converse means? Oh, it's a war between Carter and Christopher. Who's going to get it first?
Engage in a conversation.
No, not converse. A converse. To converse means to engage in a conversation with someone. Have a conversation. But we're looking for the Pythagorean theorem converse. What you got, Madison?
A converse is a theorem in verse when a theorem is written in the if-then format.
Okay, so it means that it's being written in the if-then format. Fun story, if you would have read the next line, what does it say? If-then format. Okay, the converse of a statement switches the order of the if and then in the statement. So we're going to try to write a converse of the following statements. We're going to practice by writing a converse. What does the converse do? It does what? It switches the order of the if and then statements. So let's write a converse of this statement right here. It says, if a triangle has 3 sides, then it is equilateral. So what do y'all think we could do to write a converse of this statement? What are we switching? What are we switching? If what? Three, what kind of sides? Okay, so we should be writing if a triangle is equilateral, then it has 3 equal sides. If a triangle is equilateral, then it has 3 equal sides. Okay, let's look at the next statement. If a number is even, then it's divisible by 2. If a number is even, then it is divisible by 2. So what could our statement be?
If a number is divisible by 2, then it is even.
If a number is divisible by 2, then it is even. All we're doing is changing the if-then statements. We're taking the if a number is even, then it is divisible by 2. So then we're going to go backwards. Instead of saying, we're going to look at the then statement, and it says if it is divisible by 2, then it is even. Do y'all see what we're doing? Are you sure? Okay. So we know so far that if a triangle is a right triangle, what can we use? The Pythagorean theorem. What does the Pythagorean theorem state? A squared plus B squared equals C squared. We know that if we have a right triangle, then we can use A squared plus B squared equals C squared in order to figure that out. Yes? Using the reasoning from above, our converse. Write a converse of the Pythagorean theorem below. It tells you if a triangle is a right triangle, then a squared plus b squared equals c squared. So what could our if-then statement be? Hold on. I want everybody to think through it real quick. Because everybody's doing a lot of just waiting for everybody else to answer today. So I want you to write a little sentence right here of what you think it is, and then I'm going to see if you're correct by giving you the right answer underneath it. So I want you to write the answer that you think in your head right here. I want everybody to have something written on your paper of an if-then statement that if a triangle is a right triangle, then a squared plus b squared equals c squared. We're writing its converse. Come on, Emily, pick up your pencil.
So it's in what you can do if you want to explain it. So see how it says flip on this one. Yeah, good. Yes, it's a what kind of triangle? I learned this to really well. Good job, man. Looks like this one. Yes. Pass number 16. Good job. So what did you do in the first statement? You said if a triangle has three equal sides, then it is equilateral. And you said if a triangle is equilateral, then it has three equal sides. Your statement says if a triangle is a right triangle, then a squared plus b squared equals c squared. So how could we reverse that sentence? Separating out the word equilateral and fix the one that we're doing now. Keep going. Don't. So you're on the right track.
Okay, so your statement should be, if a squared plus b squared equals c squared, then you have a right triangle. Okay, so the converse can help us prove whether or not triangles are what kind of triangles, guys? The converse can help us prove whether or not triangles are what kind of triangles? Right triangles. So we are going to use the Pythagorean theorem over and over and over again and figure out if our triangles are right triangles. We don't know if they're triangles or right triangles, but if we use the converse of the Pythagorean theorem, we can prove that they are right triangles. So let's look at it. We know that a squared plus b squared equals c squared. Which one's my a? Which one's my b? Which one's my c? Which one do I know has to be my c? This one. This one has to be my c. Why does he have to be my c? He's the what? He's the hypotenuse. He has to see that angle over there. So we know that we have 85 over here. So that we know 84 plus what?
13.
Okay, let's look at that. Does 84 squared plus 13 squared, ooh, that's a 3, equal 85 squared? You have a calculator. No. Calculators. Is it a right triangle? Why? What? No, I'm asking, is it a right triangle? How come? If a squared plus b squared equals c squared, then you have a what? Right triangle. Does a squared plus b squared equal c squared? So is the first one a right triangle? Yes. This is how you prove when you don't have a box. This is what we're trying to do. We're trying to prove it if we don't have the angle box. Okay, let's look at the next one. We have what? 15 inches, 12 inches, and 21 inches. We want to know if it is a right triangle. So what do we need to set up? How would we set up the problem? Okay, let's do our math. What's 15 squared, guys? 225. What's 12 squared? What's 21 squared? $225 plus 144, 369. Does 369 equal 441? Yes or no? Class, yes or no?
No.
So it is not a right triangle. So let's look at the next one. We have a squared plus b squared equals c squared. So which one's my hypotenuse? That's the one you always go to first. Which one's our hypotenuse? What? So we should be able to say 30 squared plus 15 squared equals 45 squared. You tell me if it's a right triangle. What did you discover? What did y'all discover? Is it a right triangle? Why not? Because they don't equal. What does 30 squared equal? 915 squared? And what's 45 squared equal? Okay, let's keep going. What about this guy? How do we set him up? Where's my hypotenuse? Which one's my hypotenuse? Who wants to say it's 24? It's usually the what? Biggest one. Okay, so we're going to do 18 squared plus 24 squared equals 30 squared. Okay, so 18 squared is 324. 24 squared is 576. 30 squared is 900. 900 equals 900, so we have a what? Right triangle. Okay, let's turn our page over. So we're going to determine if the following side lengths would form a right triangle, and we're going to show our work as proof. So all we're going to be doing is setting it up. We're going to set it up exactly like we have, but without the triangles. So we're going to take the three angles. Obviously, which one goes at the end? The big number, right? So we have a right triangle. We don't know if it's actually a right triangle or not. So we're going to set it up as 12 squared plus 24 squared equals 36 squared. And we're going to solve it. So what's 12 squared? What's 24 squared? So did y'all prove it? Is it a right triangle? No, you didn't prove it, or no, it's not a right triangle? It's not a right triangle. Okay, finish the next three. No, I think some of my stuff just like printed on over. What do you need to do? Yeah, there is a person that has their paper.
Then just this.
It's like this big.
It's like a double sheet.
It's big.
Yes.
Maybe. I know it's probably one of our expect kids. No, look at the bottom drawer of the printer. Oh.
I thought these
The big.
the one big one.
I like the.
So I'm now screwing it and all closed. It's this big. Does he have a magnifier? I'm not the same year.
I'm confused. Like, what? I have some great pictures of you from that day. Where'd he go?
Yes, it was.
Oh, is that for the But when the baby in the back started going off, they were on me because it was ugly. It was so funny.
Yeah, no, this one down.
Watch, it's on me. I was like,
It's so funny. You're like bopping
it is on me.
I didn't realize it was. I didn't realize it was.
I was doing this, I was like,
It's so funny. No, you don't. That's funny.
I did see that though, and he did great. Mr. Duyong was in a ostrich costume for the choir concert, and I took pictures of him because it was absolutely hilarious. Okay, you can go after we finish. Okay. Second one, right triangle? Yes or no?
No.
No. Third one.
Yes.
Fourth one.
Yes.
Who said no? It's yes. Okay, so now they want us to use the Pythagorean and Converse to help us answering the following questions. Okay, just because it's a bunch of words does not mean that we need to freak out. Got it? Use the information that they give you, and we're going to start breaking it down. Jimmy thinks a window frame in his house looks slanted because one corner doesn't appear to be a 90-degree angle. His wife thinks it looks just fine. It would be the other way around. But they measured the window to check and found that the width to be 25 inches, the height to be 36 inches, and the diagonal distance to be 45 inches. Who is correct, Jimmy or his wife? So let's draw a picture. Why did Miss Gode say let's draw a picture? Because it helps your brain to see things. So if I'm drawing a picture, they said that the width is what?
45.
They told me my width is 25, okay? And then my height is how much? 36. And they want to know the diagonal to be across this way. And so it should be, tell me what my length across, guys. 45. So what do we do to set this problem up? 36 what? Plus equals. Tell me who's right, Jimmy or his wife? Longest recording in the world. This is why I record it whenever after school. $36 squared plus 25 squared. The wife said it looks just fine. It's not fine? Jimmy's right?
No, it's not.
So Jimmy is right. Jimmy's right. It's not right. Jimmy's correct. Okay, so let's look at the next one. Patty wants a triangular garden in her backyard for all of her vegetables. She's going to use 3 pieces of fencing that measure 7 feet, 10 feet, and 8 feet. Will her garden be in the shape of a right triangle? Why or why not? So what do we do to set this up? Draw a what?
Image.
Draw an image, guys. It's better for your brain. Okay, so they want it to be 7 feet, 10 feet, and 8 feet. Where does my 10 feet go? On the what?
Hypotenuse.
Thank you. On the hypotenuse. It doesn't matter where the other ones go. What's 7 squared? What's 8 squared? What's 10 squared? I gave you the answer. What's 49 plus 64? 113. Is her thing going to be in a right triangle? No, it's not. Okay, and let's look at our last one. The perimeters of 3 squares are shown below. Could the 3 squares be positioned so that they meet to form a right triangle? Why or why not? They want to know if I could take this square and put it here, and take this square and put it here, and then take the other square and put it here. So they want to see if I can put all the sides of the squares together to make a right triangle. So how would you do that? They're squares, remember? Yes? Okay, so we want to know, can we fit? These are the perimeters, right? So can we get the side lengths from perimeter? Okay, how do you find the side length if you know the perimeter? Divided by 4. So let's do the first one. This one would be what? Side length what? What? 12. Okay, what about this one? $140 divided by 4. This side length would be what?
87.
Okay, so we are going to now set it up and see if we can get a right triangle by putting all of their sides together. Go ahead and do that. Can it happen? Yes. Okay, so what I want you to do is I want you to summarize today's lesson at the bottom of your paper. So I want you to write a summary of what you learned today in our lesson. After you write your summary, I want you to turn to page 281 in your books and complete the exit ticket for mastery. Perimeter. The perimeters of the three squares are shown. So if the perimeter is 48, perimeter means all the way around. How many sides do you have? Yeah. It's on the board, 281.